Thanks everyone for being here at this late hour. So the topic of my talk is enhancing photo editing with content-based recommendation system for stickers. And this is the agenda. We will talk about problem formulation, overall recommendation systems, our data collection logic, the model we used, and we'll look at some visual results, and also we conducted A/B testing. We will talk about our principles and also the results of A/B testing. So what is PicsArt, where I work? So we should understand what is PicsArt because it is the logic behind our work is interconnected with how PicsArt works. PicsArt is a creative platform. It's an editing app with various tools, and for every use case, almost for every use case, PicsArt has tools needed to have fun and turn imagination into reality. And as you saw from the topic of the talk, we will talk about stickers. But what are stickers? Stickers are PNG images that have transparent, sorry, Chris. Stickers are PNG images that have transparency and are very frequently used in PicsArt. You can see some examples of stickers here. And in PicsArt, we have millions of daily tries of stickers. And with this huge amount of data, it's becoming more and more important to align stickers with user preferences. And this is where recommendation systems come to help. So types of stickers in PicsArt, there are free-to-edit stickers and premium stickers. They vary in these four categories. For premium stickers require subscription to try, apply, or finish editing session. These are the way for PicsArt to monetize. Premium stickers come in packages. These are examples of premium stickers. As you can see, they thematically share common theme. They have much lower diversity because they also have lower volume than free-to-edit stickers. Also, they are made by professional artists. Free stickers are made by the community of PicsArt. Let's talk about recommender systems. I'm quite sure most of you know what it is. You use it every day, whether it's on Netflix, YouTube, or Spotify. If you don't notice it, they are working under the hood. And there are two major types of recommender systems, like collaborative filtering. It's working on interaction data. There is no contextual information here, just like you can represent all the data by a matrix, item user matrix. And for simplicity, like if you have user A, user B, they are similar, and this user they share these images. This is the reason why we think they are similar. If one user used this, you recommend this item to this user. The logic is very simple. And for content-based, we use descriptive attributes of items to make recommendations. Which means that click data, it's more comprehensive, harder, and this is where like deep neural networks can come to help. And so, as you noticed in the topic, we said we are using content-based recommender system. Why this? Why not use the more prevailing collaborative filtering? Three reasons that I have like mentioned. I would like to mention here. Technical limitations, like there are not enough interactions with premium stickers for collaborative algorithms to work. They are notoriously data hungry, and our experiments also saw that we didn't get good results with this. Also, product specificity. So in PicsArt, we have photo editing app, and recommendation depends mostly on what photo you have chosen. Because like if you like anime and you have chosen a photo of cactus, it wouldn't make sense to like recommend to you a photo of another cactus or another tree. It would make sense to do something that is like more related to that. So content-based recommendation system can help in this regard. Also cold start, we are going to get rid of so-called cold start problem, because even if the user has zero interaction, it's his or her first time in PicsArt, with contextual information, we can make recommendations for a user. And PicsArt is still a very rapidly growing app. We have many new users, and this is very important for us to give recommendations to them. So what we would like the ideal recommendation system to look like, for example, if this is the input photo, we would like to recommend these kind of stickers. As you can see, there are two properties for these recommendations. We'd like them to be diverse, not just recommend like, I don't know, eyelashes, or not recommend only this type of thing, but diverse things. Also, surely the most important thing, they should be complementary to the input image. This is high level. And mathematically, what we would like to do, this is the photo. We would like the photo and relevant stickers to the photo to embed, to project them into another space in such a way that they are close, and stickers that are not associated with this image should be further away. This is what we were trying to approach, and this is achieved in machine learning with metric learning approaches. There's contrastive learning, and this is the high-level approach. What it's going to do for photo, this kind of photo. For this photo, we are going to use a positive sticker. This is going to be moon, which could be complementary for this. And as negative sticker, we are going to use something like this. This is an easy negative, but yeah, with enough data, should also learn to discriminate stuff like this. More on the model architecture later. So let's talk about data collection, what the data should look like. Data is pairs of photo and stickers, carefully picked. And this is actual example from training data. And what is interesting, what proved to be the most challenging part was the data curation, because for many months we couldn't get good result, and we had to like do filtration on. We had to get rid of 99% of the data to get good results. We did very strict filtration. And the metrics for this quality filtration was the number of remixes, the edited photo, the final photo that the user got, and why use like remix. And first of all, like, what is remix? It's a PicsArt specific thing a little bit. You might know remix from music and stuff like that, but it could also be applied to photos. This is the original photo. Other users in PicsArt use this photo, edit it, and get new photo. And the other user also uses this, gets new photo, and like that. And remix is the aggregated human feedback in PicsArt, and also it reflects active engagement in creative community. In contrast to like comment, which is passive and weak signal, remix is very strong signal, and if you choose to engage with this content, you really like the content, otherwise you wouldn't. So we use this metric for filtration. And also one more interesting thing we did with data collection. For example, user used this photo and used this sticker on the photo, and then used this sticker, and then used this sticker. For data collection, we could choose this photo and this sticker, this, but we don't use that logic. We separate the data into intermediate data. For example, this, and afterwards they use this sticker. We make the photo like this. So we separate it, which makes the data much richer. And let's talk about like naive approach. Why do this training? Can't we just use like feature extractor and like just calculate the distance and from photo to the nearest sticker and take it as recommendation? No, it doesn't work. As you can see here, we have photo of a person. Sticker also is all stickers of persons, but it's not complementary. It's just similar to the photo, and it wouldn't work. It would work like if we wanted to do like photo-to-photo recommendation. It would work fine, but we have photo to sticker, two different entities, and they are complementary. Let's talk about the deep metric learning. What we used here, like we use this called Siamese network, and simultaneously we copy the full network 3 times. First, if we have 3 inputs, positive sticker, photo, and negative sticker. We calculate the embeddings, and on the positive distance, negative distance, we subtract from positive distance, negative distance, add some margin, take the ReLU, and this is the loss. Standard thing in metric learning, and where we deviated from standard approach is in standard approach, these all networks are copied and share the same weight. We deviated from this, and for each one, for photo and for stickers they share, but for photo and sticker they differ. We don't share the weights, and here you can see the trained already visuals why we did this. This is the shared weights approach. As you can see in the photo, here is a person, and in recommendation, persons also appear. And when you don't do shared weights, it's all complementary recommendations. Because when you embed photos and you want positive stickers to be close to the photo, and automatically the stickers that are visually similar to the photo will also appear. So that's why we don't share weights, and this also improved our evaluation metrics. And as for evaluation metric, we use standard approach. We just recall. Also, on the side note, we calculated diversity of the stickers. We didn't want the stickers to be repetitive. This was also something we always kept in mind. Of course, we did many experiments. We experimented with different laws, even with cross-entropy laws, the standard contrastive laws, NCA, and also we tried different feature extractors. And to our big surprise, we didn't. So for feature extractors, we didn't notice any major improvement when we were using inception instead of mobile net. So big and deeper neural networks didn't yield good results. And in the losses also there, like this novel metric learning losses also didn't prove much. Most contribution came from the data. And after the training, we can talk about the whole production setup, how it works in PicsArt. So first of all, we have data collection job that takes data from our data lake. This job then sends request to data collection service, which updates our MongoDB with feature extractor, extracts the feature of the images, puts it here. And this is a batch job that works, daily or weekly, doesn't matter. And when on live job, where user clicks on the PicsArt and opens editor, immediately the input photo is uploaded. There's a separate service that uploads the image. And upon user clicking on sticker's chooser menu, when he or she wants to choose sticker, request is sent to PicsArt backend. Backend sends to PicsArt sticker service. Sticker service sends request to feature extractor, and feature extractor gets the features from the uploaded image, also sends the candidate stickers features to service. Service does similarity search here, and after that we get recommendations, set that to backend, and backend shows the recommendations to the user. This is our whole pipeline works live. And we talked here about candidate data collection, and we have separate job for this. We don't use the whole PicsArt data. For premium stickers, as we talk, they are a magnitude fewer than free stickers. So for premium stickers, the approach is straightforward. We take the whole available data. It can change, but we have a job that checks it. And for free stickers, we also use remix of the stickers as filtration and take top percentile of stickers. This does two beneficial things for us. Of course, it is most resource efficiently. It's one thing to do similarities on 100,000 images, and this other thing on 100 million. Also, it gives us higher quality control. We are the ones choosing it, and aesthetically not pleasing images won't appear in the recommendations. Also, we try to avoid possible duplicates because we are working in visual space here, visual features. Near duplicates can appear in recommendations. We do difference hashing and deduplicate the item pool. Here you can see some visual results of our already final model. For this image of eye, as you can see, we have quite diverse stickers. Here also, thematically, we can see stickers match. Here also, this is green also can be seen. We can see complementary recommendations here. And also here we can see also spiral already on the photo, and model detects it and suggests more spirals. And yeah, by the way, guys, if you think some stickers are not matching. This is very domain-specific recommendations. It's very useful for PicsArt, but might not be very useful outside of it. This is like the reflection of our users' taste. And here you can see, like, for bigger image, it's Halloween spooky stuff, also quite diverse. And we also, this was for premium stickers, and we also have stickers for recommendations for free stickers, which are much more diverse, magnitude higher diversity here. So yeah, here this is from Fortnite, and without only from visual context, understand that this is like Fortnite game and suggests characters from the game. So here. Okay. Let's talk about our A/B experiment. In PicsArt, we always try to do data-driven decisions, and almost all our features go to A/B testing before going live. And we might like metrics might be very high. We might like the model very much, but our users might not like agree with us, and maybe it's not fit for them. So we always do A/B testing, and A/B testing always begins with our hypothesis, like what we think our model is going to give. We think that the model will increase content engagement for users. This was our main goal. So we have developed an A/B pipeline, and it begins with hypothesis, and afterwards we identify main metrics we want to influence. We do careful data sanity check, which check all events that we are going to calculate, whether there are any bugs, how to calculate them, so on, if there are any inaccuracies. Afterwards will be standard statistical thing, which is power analysis. We identify main metrics, choose alpha, beta, minimum detectable effect to find out the number of participants. We fix this number, and as soon as the number of participants are achieved, we stop the experiment. We don't do any kind of cheating here. We don't look at the data before. And so afterwards, of course, we do metrics calculation. We do the testing. We usually do standard statistical tests like z-test and student t-test. And afterwards, of course, we make conclusions on what we achieved, how can we interpret the results, and of course, like rollout decision, whether it goes live or not. So in this experiment for premium sticker recommendation system, we chose our users as randomization units. We identified two cohorts, subscribed users and non-subscribed users, and all the metrics and statistical tests were separately calculated for subscribed users and non-subscribed users. Overall, the experiment had 650K participants. And let's talk about our A/B results, what we achieved. So overall user engagement with stickers increased. Not only premium stickers which recommendations were made on, but overall all stickers. For subscribed users for whom the premium sticker recommendation was mainly made, global level is like not only the touch point where user sees the recommendation, but overall the sticker engagement increased. Sticker apply try conversion also increased. And what's more important for us, up open retention among subscribed users also increased. And yeah, after all, after these good results, rollout decision was made for the model. That's it. Thank you very much. Feel free to ask questions. Yes, please.
Do you perform pre-classification if it's a video game before getting or it's just
No classification. This feature extraction just has like this classification in it. It was trained on classification, these feature extractors, classification task, and no, we don't do anything like that. It's just learned purely from our data.
I'm just wondering why do you offer like images over light or whatever, so moon or sun? I don't know why exactly.
It just came from our training data, because on our training data, users didn't use moon or something like that, and you might, I think, agree with me.
Users, okay.
Yeah. It's just user data. We use pure user data here. And users just don't do it, and this differs from like natural scenery that you can see in other things. If it wasn't gamified thing, I think it would recommend trees and clouds and something like that.
I didn't recommend it. I didn't play it, but I don't have this in training.
So I have a couple of questions actually. Did you consider using a hybrid model? Like you said that you don't have enough data to do a collaborative one, that's why you chose content. Maybe for some users you have data enough to go for a hybrid approach and do collaborative for them and content for the rest.
I mean, we do collaborative filtering, but on free stickers, we do this approach because we have a good amount of data. But no, it just also doesn't work very well. I mean, you are not able to get good item embedding. Because this is like the embedding you get for collaborative filtering also depends on like co-interaction matrix with other users. Like, do you have like similarity with other users? When there is very few interaction with stickers, you can't get similar users.
Second question is regarding the metric. You mentioned that you have used recall. I wanted to know if you have considered using something like MDCG. Or the rank or the order of the recommendation is not important for you.
I mean, it is important, but what we did is we did recall at 10 if I'm not mistaken. It is very important for us for the stickers to be like, this is like recommendation is PicsArt coming pages, like for first page. In first page you can see like, I don't know, 15 images. It's like very important for us for the sticker to be in like first 15 images. And so then we were considering NDCG, but recall was like, okay, metric for us, simpler. We didn't go deeper.
And the last quick question. Do you remember what were the gains after the A/B testing? Is it like 2 times higher or like?
I'm afraid I can't say numbers. But yes, significant increase. Statistically significant. Yes, please.
How did you handle the novelty effect? When you deploy something new, users initially see that something has changed and they engage more. But then after like a week, they get back to normal. So
yeah, very good question. Our A/B test lasted quite long because we were testing on subscribed users and gaining many subscribed users, like of course are only a small fraction of all our users. We needed to get significant amount of participants for tests to work best. So we had like quite a big amount of time to test, and I think users had enough time to get bored of our recommendation system and didn't. And of course, after A/B test, we have constant monitoring and we monitor metrics. And if we see decrease, we will change something.
do you do like reverse of the A/B testing, like when you deploy a feature, wait some time, and then for a small fraction of users, undeploy the feature?
No.
Check if the metrics go down for them.
No, very interesting approach, but no, because A/B testing is like a very resource-heavy thing. We have many other models that are going to be A/B tested. We can't like do something like that.
Part I didn't understand clearly. So, in order to find out stickers, like related stickers, so you take the image, you do segmentation, extract this considered as a sticker, or you have some database where you wrote that for this kind of image, I have this kind of association?
No. It's very simple. You have image, you get a vector for that image through neural network. You have, I don't know, 1 million stickers. You get vectors for that 1 million stickers. And then find the closest vector for this image from these stickers. We won't recommend those closest ones.
So what's the criteria? Or what is the criteria of closest?
Euclidean distance, just Euclidean distance. Yes. We normalize, so on with ranking, it will be the same as cosine similarity.
Okay.
So yeah, but we do Euclidean distance works pretty well.
So do you, for the training data, is there any heuristic to use images for training data? So take the images where I have as much object as possible inside it, or it took randomly?
No. We didn't take images randomly for training. As I said in data collection, We use stickers that our users like the most throughout the whole history of PicsArt.
Input images are
Yes, the input images. The input, these pairs that I talked about. Just a second. Here, this image and this pair would appear if this sticker was applied on this and the final image, the edited final image, was liked by the majority of PicsArt users. We consider this a very high quality image. We know that this matches with this because otherwise you wouldn't like that. And we take these pairs as training image. Any more questions, guys? Yes,
Do
please.
you have some kind of hashtag system or user-based classification of images? Can you use them like with features? Like, you know, a Harry Potter image, so you advise them Harry Potter stickers.
When we use something like this in search, but yeah, not here. Visual information could work quite well here.
You mentioned about the models that you're trying as a feature extractor, and they were mainly CNNs.
Mm.
Have you tried transformers?
Yes, we tried clip.
The question, and the second part, stickers, maybe they need feature extractors of lower capacity, because they're smaller, or do you use same architecture for those features?
No, so for the first question, yeah, we tried clip. We gained some marginal benefits, but the cost of running it was not comparable. So we stopped with, we ended up with MobileNet because we did user study and users couldn't distinguish between the model trained on Inception, ResNet v2 and MobileNet, which was very funny. Yeah, and we tried clip. Yeah, it was marginally better, but you know that it's and could you please repeat?
And the second part of the question was whether the stickers and the images, do they need same architecture for feature extraction? Because stickers are smaller, I guess they may need a more feature extractor of lower capacity.
No, I mean we used, as far as I know, 299 by 299 input, and most of our stickers are bigger than that. So yes, we didn't use that. Thank you very much.